All right, guys, we're going to learn about what is called the standard normal distribution. And this is, once again, essential to this class and to Stats 250. Now, since each normally distributed variable have its own mean and standard deviation, the shape and the location of these curves will vary. No distribution, or rather, we cannot assume that every distribution will have the same mean and the same standard deviation, whether if it's light bulbs, like we did for the last one, or weights of newborn babies, or even prison sentences, which are all normally distributed variables, does not have the same mean, nor has the same standard deviation. Therefore, sometimes it will be complicated when it comes to finding the percentages and probabilities for a variable. To simplify the process, statisticians use what is called a standard normal distribution. It is a standardized value used to find the probability and percentage of a category. The standard normal distribution is a normal distribution with a mean of 0 and a standard deviation of 1. Standard normal distributions are known as standardized scores or z-scores. A z-score is also a measure of position. So we have percentiles and we have z-scores. In Stats 250, we will dive further into z-scores. A z-score is a number of standard deviations that a particular value is away from the mean. To find the probability of the z-score in an examination and the probability of z-scores, we will use what is called a standard normal distribution chart or a z-score chart, which is going to be attached to this lecture. And also we'll be using it for the remainder of this lecture and also for the next section of the lecture. Now, here is the way to read a standard normal distribution chart. And I'm going to pull one up right now. This is what a standard normal distribution chart looks like. Now, there are two sides to it. There's a negative side for z-scores, and then there is a positive side on the second page with z-scores, page 1 and page 2. Depending on what the z-score is, you will determine which side you will use. Now, suppose we are looking for the probability or the area under the curve for the z-score of 1.39. The way to read this is, because it is positive, start at the top where the z is at. And we're going to look at 0.0. Take the first two numbers of that z-score, which is 1.39. So the first two numbers will be 1.3. Scroll down to 1.3 on the z-score chart. Use the last number, which is 9. That represents 0.09. After that, you're going to use the top set of numbers to move along 1.3 until you reach the 0.09 at the top. And that is the probability, 0.9177. If we look here, same chart. Start here at z, we're at 0.0. We want to scroll down to 1.3. We want to find the z-score for 1.39, which means using the top set of numbers, we're going to scroll over to the 0.9 or 0.09. And that is our probability, 0.9177. So yes, that is how we find the probability of the z-score. Now, when we're doing problems like this, we also have what is called shading the area in response to the z-score. And when you're shade under the curve, you have several directions. We're going to focus on 3 directions of shading in this case: shading to the left, shading to the right, and shading in between. And remember, a z-score is a measure of position, and a measure of position represents a percentile. Percentile represents the percentage, which can translate to the probability that a particular score is above the rest of the data values. Keep that in mind, because the standard normal distribution curve works the same way. If we are dealing with shading to the left, when it comes to a standard normal distribution or a normal distribution, the probability of the z-score is the probability that we will use in our final answer, which means every probability on this curve is shaded to the left. Scroll down to the bottom. Here is your z-score. The area is shaded to the left. Go to the first page. At the bottom, it's a smaller section, but still the area is shaded to the left of z. So that means when we're dealing with left shading, whatever we get as the answer based on the z-score is going to be our final answer. Number 2, find the area under the standard normal distribution curve to the left of z equals 1.73 and to the left of z equals to negative 2.33. So we're going to draw the standard normal distribution curve. Okay, so it's a bell-shaped curve. And remember what it says. When it comes to the standard normal distribution curve, the mean is 0 and the standard deviation is 1. So in the middle is going to be 0 and my standard deviation is 1. So every time I move to the right, I'm increasing by 1 unit. 1, 2, 3. When I move to the left, I am decreasing by 1 unit. Negative 1, negative 2, negative 3. To the left of 1.73. 1.7 is between 1 and 2, closer to 2. So we'll put it right here. And it says we're shading to the left. Okay. Now, let's find the probability that z equals to 1.73 on our standard normal distribution curve. It is a positive z-score, so we look at the positive side. 1.73. So we're going to go down to 1.7, move over to the 0.03, and that probability is 0.9582. Because this is shaded to the left, that is going to be our answer. The probability that z, and we're going to use the less than symbol to represent left shading. Same process for the next one. To the left of negative 2.33. So let's reconstruct the bell-shaped curve. Negative 2.33 will fall right about here. and we're shading to the left. Let's find the probability of z equals to negative 2.33 on the standard normal distribution curve or on the table. Look at the negative side. Go down to negative 2.3 over to the 0.3. That probability says 0.0099. Because it's shaded to the left, that is our final answer. All right, guys, that is it for this video. Hope you enjoyed it. Ran kind of long, but I'll see you soon. Take care.